Okay. Yeah, I guess we're back online, and we are back in a YouTube stream, and I see that uh, the amount of people who were there kind of balanced out. Sorry for the inconvenience. We had some technical difficulties with the streaming platform, but now it seems like it's fixed. I'll be looking at the chat for your feedback if there's something wrong with the stream or with the sound, but I'll start over. So again, my name is Ivan Tarasov. I'm a sales engineer at Things Industries. And in this webinar today, I'm going to talk about and show the migration procedure from other open source network servers to the ThinkStack Cloud. So what I'm going to do is to go over a couple of points in text of what this is about, and then show a quick demo with various options of how you can transfer your devices. So let me share my screen. And yeah, so I hope you can see my screen now. And first thing I have open is our documentation portal. I'm gonna zoom in a little bit so it's more seen. So this is the point of reference where all that I'm talking about today will be, you can refer to online. So there are various things. So today we're going to go over migrating from ChirpStack network server to the ThinkStack cloud. So for this, we are using a tool called LoRaWAN Stack Migrate. And in this section, you can see all the commands that are going to be performed in great detail. And the tool itself is also available on GitHub with all the features that are currently supported and with options to either download the source and build it and run it from source and maybe hack around and play around a little bit, or you can download binaries here as well. You can see which targets we are supporting currently. So the ThinkStack v2, ChirpStack, and the ThinkStack Community Edition to the ThinkStack Cloud, and are almost ready with the Firefly network server, and Laureate is also currently under development. So with that being said, I have a small lab here in my home deployed. So I have ChirpStack network server running locally on my machine. And for that, I have connected one gateway that's on my desk. Then that's going to be simulating the network that we are migrating from. And I have the ThinkStack Cloud application, my account, where we are going to be migrating. So let's go over my migration that I want to, my deployment that I want to migrate first. So I have my gateway and I have two applications. So first thing to really think about is the migration really takes care of devices and applications. So for example, if you're migrating to another network server, you need to make sure that there is a gateway coverage that points to the destination. So in this case, to the ThinkStack cloud, for your devices to actually start talking to the ThinkStack cloud that you are moving your devices to. If there's no gateway in the vicinity of these devices, obviously they will not appear in that network server. So that's why I said that I have here both a gateway that's connected to the ThinkStack and a gateway that's currently covering my devices here. So what does it look like, the migration procedure? So there are several ways to go around it. First, I have in my ChirpStack, I have one device. This is not the device that's real. It's just, let's say, a device entity. It has all the keys and device CUIs, but it's never been seen. So this can happen that for you also, if you have in your applications devices that were not yet activated, maybe you are going to install them further, you just have created them, in the network server, that's totally not a problem. So I will now move to the command line interface and show you how to work with the tool to migrate your devices. So we are going to first, according also to the documentation, set up our tool with some environment variables. So it can also be done with, for example, file. So I will create an environment file and I will edit it so it make it a bit better. So I have this empty file, and in this I'm going to one by one put in the variables that I need. So first variable is the API URL. So that is the address of the network server that we are going to migrate from. In this case, for me, it's localhost port 8080 because the chirp stack is running on my machine. The second variable that's very important is the API token. That is an API token that's you create in chirp stack, such that the tool can talk to chirp stack API. So I already have created that key, and I'm gonna find it. Yeah. So I think this is the one. Put it also in this file. Next thing we need to specify is the frequency plan that the devices that we're working with, and we're going to set it to EU. So all my devices in the deployment I'm migrating is in EU frequency plan. And the next one is the environment variable to show whether the API is secure and insecure, whether it's using HTTPS. Just in case, because I have it deployed locally, just in case, I will set it to insecure true, because I don't think I have HTTPS set up. But anyway, these should be all the variables that that we might need for this migration. So I'm going to source the file to make sure that these variables are now in this execution, and we can move on. So the ways, as I said, you can do migration. You can do it for individual devices, and you can do it for applications. So we'll start with the individual device. This is the command. So what is noticeable here? Yeah. So what is noticeable here is that I'm specifying source chirp stack, and the field the device is the device EUI. So it's not the device name that it can be that is displayed here, but it is actually the device EUI that can be found, for example, here. Or you might already have a list of the device EUIs that you want to migrate, and in this case, you can specify it in a text file, feed it to this command. So there are some options that can also be specified here. So just just to take a step back, what's actually happening when we do this? So the migration tool calls the API of the chirp stack, finds this device, collects all the necessary information that it has about it, like identifiers, like session information, and puts it in the JSON file that we specify. It also deletes the device entity from the chirp stack network server, such that the device can safely talk to the second network server, so there's no race condition happening. Now, if we if you want to just test with one device that's not active, or so you don't need to, you can specify a command dry run, and this will allow you to create this JSON without deleting the device from your network server chirp stack, just to test the various ways of how you can how you can do it. So let's do it with the dry run. we can see that the command has executed correctly, and we see the content of the JSON that got actually exported. Now, if we format it, that's the information that's retrieved from the chirp stack. It's all that the device has so far. It's the keys, the EUIs, the file version information, and things like that. So now that we have this JSON, the last step is just to import the things stack application. Now, import this device in any application that we already have. I will use this application that I have and just select this JSON file. Let me see if that's the right one. Yeah, that's the right one. And what we can do here also is to specify some parameters that will be used as fallback in case the entities in chirp stack did not contain them. So fallback is the frequency plan, the LoRaWAN version, and the PHY version. So this device has it, but it might happen that the device doesn't have it for some reason. In that case, these values would be used to create the device in the things stack. So I will just, we can see the same information. We can see now that the we're set to the things stack. Everything is fine. And we have this device here in the things stack. That's pretty easy, right? That's easy because this device was not active yet. So we just transferred in a convenient way all the fields that we might need to otherwise transfer manually. So what about the devices that are in chirp stack already activated and working? So I have another application here in my chirp stack where I have two more devices that are just dummy devices. And I have one generic node that's actually sitting right here on my desk that's sending messages. So it's an OTA device that has a session established. It's counting frame counters. It has the session keys and everything. So how do we move this device to the things stack without actually losing the session? Because we don't know whether the device will rejoin in an hour or in a week, right? If it rejoins in a week and we move the device without the session to the things stack, we will lose the week of data. So for that, we have for that, the migration tool actually also grabs the session information of the device. I'm going to show this, and I'm also going to show another way of doing, of exporting actually the whole application. Application, we will move it to a file.application.json. And instead of device EUI, obviously, to specify the application name, which is test. That's the name of my application. I'm going to remove the dry run flag here, such that the device that's working here now can actually continue its session in the things stack. So yeah, I think everything seems fine. Source chirp stack application. Yeah. So let's do this. Okay, everything is completed. Now we should see that test. No, devices still exist. Let's look at the content of this file. Yeah. Okay, it didn't delete, but export the information about all three devices in my second application in chirp stack. Now you can notice that apart from the information about the device that we had for a dummy device, there is also a field called session that contains the session information, which in particular is the device address that it has already been assigned, session key ID, session keys, and the frame counters. It is very important to make sure that the session persists when we move. Now we have all this, and as you understood already, the application does not actually allow you to have like an application entity to import, but like it exports a group of devices. That's the whole application, but you still import them in an application in the thing stack. Now, okay, so since I don't see that, just not to mess it up, I will stop my chirp stack just in case. So I run it in Docker Compose. I will stop it now. And I will create another application. And here I will import. So it, for example, the use case could be that you export this application test, and yeah, actually I can just create an application test. So it can be, you know, one-to-one, and yeah, no, we cannot register an application with the name test. Let it be test one. And here I follow the same procedure. I import the devices. I use the JSON format, and I select this JSON that I have just exported. Upload it. And all three devices imported successfully. That is great. We see them, and we see this generic node that was active in the chirp stack. You see that the frame counters are preserved, and the session is preserved because the device address is also here. So even without joining the thing stack explicitly, this device can already work with it. We see that there is no activity, probably because the device just hasn't sent an uplink yet, which is absolutely fine. I'm going to try to make it. Or maybe we will have to. Oh yeah, okay, okay. We see already. So what happens here is that the device continues its session in the thing stack. However, the thing stack still needs to adjust some MAC parameters like channel list and RX timing. So it pushes a downlink to the device, but again, it's still all within the existing session, same device address. And after that, the device will save this new configuration, MAC configuration, and it will continue sending uplinks or downlinks or whatever that might be. Yeah, we can actually already see that the uplink was received before. This negotiation is happening, and after some time, we'll be able to see that the uplinks also continue flowing. Yeah, so we see the uplinks, and the device is migrated. Now you can imagine that the same can be done at scale, thousands of devices, just one JSON file per application, and you can completely move the whole logical separation that you have in chirp stack to the thing stack as well. So yeah, I guess that is pretty much it on the demo side, and about everything I wanted to say. And I want to remind once more that it's important that to do this and to preserve the session of the device and to make sure it continues communication, you need to have a gateway, a takeover gateway that's already there in the vicinity of this device, of the new network server, so of the thing stack. In that way, there will be no interruption in the communication. But yeah, that was all I wanted to show today. And I think, yeah, we still have a little bit of time. So if there are any questions, then feel free to drop them in the chat, and I will try to answer them either on YouTube or on Restream. I see both. So yeah, let me know if there are any questions. Otherwise, yeah, feel free to navigate to our documentation. I am sure we are going to post the link to this and the link to the GitHub repository as well. And yeah, that's it. So as you might expect, the similar procedure will be available for other network servers as well in some time. So yeah, I'm gonna stick around another 5 minutes maybe to see if there are any questions. All right. I think there are no questions. So then thank you very much. Thanks everyone. Make sure to, if you in 5 minutes realize that you had a question, you can reach us at sales@thetingsindustries.com, or you can reach me at ivan.turasov@thetingsindustries.com, and we can post it in the chat. And we can help you with migration, yeah, ad hoc as you want. So that would be it from my side. Thank you all very much for being here. I hope you found it insightful. And yeah, I'll see you next time.